Continuing on with quadratic review, we want to make sure that we understand the key points. So there's graphing and the different forms of the graph. There's solving quadratics. And the main idea behind quadratics is that or a big idea, is that they are symmetrical. And we can use this property of symmetry. So it says here, find the axis symmetry and the symmetrical point to the y-intercept. So first of all, I'm just going to sketch this graph. Okay, we're going to have a y-intercept of, we need to figure out the vertex if I'm going to draw this. So I need to first of all find the vertex. So I can find the vertex one of two ways. Use Vertex Formula and or complete the square. So I'm going to complete the square in this case because I want to know the y position of the vertex. So to do that, we want to complete the square with only the x squared. It's hard to make a square with two squares, so we want to just use the one square. When we do that, we need to factor that out of the second term, and we want to put the constant on the outside. So once we have this, we're going to use the bracketed part and complete the square. So I'm going to take half of -4, square it. Then I need to make sure I balance the equation. So I've added two groups of 4, so I have to subtract 8 to balance that equation. So once I have this balanced, I can write it in the graphing form. So 2x minus 2 squared minus 3. And that's going to give me my vertex at +2, -3. So somewhere around here. So that's going to be at 2. And this is really important in that it gives me the axis of symmetry. Okay, so we're talking about the symmetry. So we want to know where it is symmetrical. It's symmetrical through x equals 2. So sketching this graph in, I know it's got a y-intercept of +5 somewhere around here. It's going to go through the vertex and back up through here. And we're trying to find the symmetrical point to the y-intercept. That would be that point there. And we're going to find it right there on my graph. Okay, so the axis symmetry, I'm just going to enter that part. The axis symmetry is at x equals 2. To find the symmetrical point, we can just count. I can count 2 from the y-intercept to the middle, and then 2 further. So that's going to be at x equals 4, y equals 5. And again, just make sure that we're clear that's at y equals 5. Okay, or we could use, so that's going to be, we can probably count to 4. We can do this another way, and we can just say that, well, let's say we don't know that. We'll call that x, and we can use the middle formula. So the middle between the the y-intercept and the symmetrical point, the average of that will get us to the middle coordinate. Okay, so I'm just going to highlight that. That 2 comes from there. And then I can just solve for x. So solving for x, I'm going to get, cross multiply that, I get 0 plus x equals 4. And there's the coordinate, the position of the symmetrical point to y equals 5 and x equals 0. So there's my symmetrical point. So using symmetry is very useful. And again, that center line is really important when we're talking about quadratics. Solving, we can solve lots of different ways. We could try to factor this, but there's no numbers that multiply to 9 and add to -4 or have a difference of 4. So we're going to use and just jump to the quadratic formula. I can complete the square, but the quadratic formula tends to be easier. So I'm going to do the negative of -4 plus minus square root -4 squared minus 4 times a times c. Make sure I keep track of my negatives here. So divide by 2a. Again, I'm just going to make note of this, that double negative means I'm going to add. Okay, so I just got to make sure that my answer is going to seem reasonable. So x is equal to 4 plus minus the square root of 16 plus 4 times 9 is 36. So that's going to be 52. Okay, so it's going to be 4 plus minus square root of 52, and that's all divided by 2. Now that is the correct answer, but we're going to simplify this. So 4 plus minus, I'm going to take the perfect square of 4 out. So it's going to be 4 times 13. And that perfect square can come out of the square root. Okay, and then we end up with 4 plus minus 2 square root 13. And then we can simplify that to 2 plus minus square root 13. And that's the solution to that quadratic equation. So this is a problem where we're trying to find the equation of the parabola. So we have to decide what type of equation we want to use. We're given roots. Okay, so we're given roots, and so we want to use the, well, we should check the rest of it. So y coordinate of the vertex is y equals 8. Well, that only gives me the y coordinate. It doesn't give me the full vertex. So we're going to go with the roots here. And given the roots, we want to use the factored form. So y equals ax minus, we're going to go plus 3 x minus 5. So from the roots, we get the factored form. Now, it is possible from the roots to get the p-value, and then we have the vertex. So I'm just going to start here. Once I have that, I want to use the y-coordinate of the vertex to be able to write this equation. So the y-coordinate of the vertex is y, but we need to know where the x-coordinate of the vertex is. So to find the x-coordinate of the vertex, so imagine what this looks like. We've got a -3, +5, and we know the y-coordinate of the vertex is up here at 8. And the middle line, that middle, is going to be halfway between those 2 points, or 5 plus -3 divided by 2. That's going to be at y equals 1. Or sorry, x equals 1. So at x equals 1, we have the middle coordinate. Okay, I'm sorry, just going to make that a little bit neater. At x equals 1, we're going to have the middle coordinate. So I can plug my vertex in now, okay, and I can find out my a value. So my vertex is going to be at 1 and 8. So I'm going to plug 8 and 1 into my equation. So I end up with a 1 plus 3, 1 minus 5, and then I can solve for a in this equation. So 8 is equal to 4 times -4, so I get -16a. A is equal to -1/2. And that makes sense because it is an upside down parabola, so we should expect the a value to be negative, and we get y equals -1/2 x plus 3 x minus 5. Okay, so that is the factored form. Now, some of you may have chosen to find the vertex point of 8 and 1, and starting from the vertex point, we could actually put it into the graphing form. And so this is an alternative solution where we could start with the vertex form, x minus 1 squared plus 8, and then we can plug in one of the roots. So y is 0 and a, it doesn't matter if we use 5 or -3. I'm going to use 5 in this case, and then I can calculate my a value. So we should get a is still -1/2, so I'm going to subtract 8 from both sides, and I get a is equal to 4 squared, a times 4 squared is 16, and again I get a is -1/2. An equivalent equation in the graphing form is at a of -1/2, and again notice that it matches and it has to match, but now I've written it in the graphing form. Okay, so here I have the factored form of that equation, here I have the graphing form of the equation, but they are the exact same equation.